going to go into that. But once you've determined or decided, okay, I'm going to use a naive forecasting or smoothing, exponential smoothing, or either one of the four, how do you go about it? That's what this video is about. We'll talk about what naive forecasting is, what moving average is, weighted moving average, exponential smoothing, what those guys are. So, naive forecasting is really what it is. It's very naive, and you don't do too much. You simply take the forecast of the previous period, the actual sales rather of the previous period becomes the forecast for the next period. So if you look at this example, here I have 10 weeks and we want to forecast the sales for the next 10 weeks. So we start with week 1. And the forecast for week 1 is simply going to be the sales for the previous week, which we call week 0 in this case. So the forecast for week 1 is 110. And during week 1, you go through whatever you do for your organization. If your sales ends up being 95, then that's what it is, right? So that's going to be the forecast for week 2, 95. And then you determine the sales for week 2, let's say 105. That becomes the forecast for your next week. So I can actually just use Excel to do this. And let's copy the formula. Okay, so as I'm filling in the actual sales, 98, 110, 100, 115, 112, 10, 5, you know. Now, there's nothing to this forecast. It's just picking the previous period's actual sales and using it to forecast the next period. There are some metrics that we normally calculate for forecasts. For example, we calculate the error, which is sales minus forecast. So that's equal to this minus this. We also calculate the absolute error, which is just the absolute value of the error. And I can do this for every column. So we have all our values there. For week 10, okay, well, what value shall I put here? Let me put 100 here. Okay. Two other metrics that we could calculate here is squared error. That is the square of error. And we could also calculate the percentage of error. Percentage of error. The squared error is just the square of the error. So that's going to be, this column is going to be square of this times this. And the percentage of error will be the absolute value of error divided by sales, everything times 100. this column divided by sales column, everything times 100. Okay, so copy and paste. And we can find averages for all of this. Because we're forecasting for week 10, really, so I'm going to remove the last column here. So now we have our sample space size to be 9, and we can calculate averages, which will be average will be equal to average of this and this. Let's paste. So in this case, our average absolute error is 8.7. Our average squared error is 97.8, and average percent error is 8.36. Those values become even more important when we start thinking in terms of weighted averages and how moving averages for forecast, and how do you pick your moving window. The next forecast to consider is what's called moving average forecast. I just created a copy of the worksheet so that the sales stays the same. This what's it called? This matrix here, forecast accuracies, will get updated as we go. So I'm not changing them so that I don't have to rewrite the formula, but they will get updated as we fill in the averages, the forecast here. Now, to do a moving average, you have to decide how many periods to consider. Let's say you choose to consider 2 periods, that is two historical periods, in calculating your forecast. That means you take period 0 and period 1, because we're using 2 periods now. You find the average of that. That is the forecast for your next period. If you choose to go with 3 periods, then you add up period 0, 1, and 2, calculates the average. That's the forecast for your period 4, for your period 3. So whatever the size of your moving of your window, just add it up, divide it by the number, and that's the forecast divided by n, the number of periods. That's the forecast for your next period. Now the problem with this is if we are taking a period of 3, if we're taking a window of 3 periods, that means we can't do a forecast for period 1, and we can't do a forecast for period 2. So the earliest period or the earliest week we can forecast for will be 3, and that will be equal to, if we use this formula, if we use Excel to do this for us as well, that will simply be the average of this this. Okay, and you see how all these columns get populated immediately, updated immediately. We don't have anything here, so there's no forecast accuracy to be bothered about for weeks 1 and 2. If I copy this formula here as well, and I believe I can paste it all the way here. Okay. So let's come up with a sales value for week 10. Let's do 100. Okay. Let's see. What if I format cells? Let's just make it number. Let's make 1 decimal place. Okay, that's more readable. Of course, when you consider the averages of the forecast accuracies, that is the absolute error, the squared error, and the percentage error, they are means. Where you consider the one for the moving average with the what we got for the naive forecast, our forecast is actually better. We have a mean absolute error of 8.7 before. Now we have 6.54. Okay, so it gets better, which makes sense because we are doing a moving average in this case, not just copy and paste from previous sales. The next forecasting method is the weighted moving average. It's quite similar to the moving average we just saw, except that for the weighted moving average, you apply a weight to each of the previous data points. What do I mean by that? So let's stick with our 3 period moving average. For each of the 3 periods that we want to consider in our forecast, excuse me, we have to apply a weight to each of them. And the weight that you will apply will probably be dependent on, what you noticed about your data in the past. So for this example, I'm going to keep it very simple. We'll apply 0.2 to the first one, 0.3 to the second one, 0.5 to the third one. You will apply weights as as your industry or your organization determines. The only thing is the sum of your weights ought to be equal to 1. So instead of just using the average function in Excel like I use the other time, I'm going to make a little change by doing this. So this would be, let's say, times 0.2 plus times 0.3 plus times 0.5, and all of that divided by 3, since we have 3 data points. Okay. If you copy this function, just apply it to the remaining columns. Let's look to be sure that, so E7, E8, E9, E8, E9, E10, and on like that. Good. And of course, our forecast accuracy gets automatically calculated for us. So let's compare this weighted moving average forecast to our previous moving average forecast. Our mean absolute error here is 71.87. Here it's 6.57. That looks strange. Let's see. The mean absolute error for our weighted moving average is pretty bad. So in a situation like this, if you are the one deciding which forecast to use for your organization, you most definitely not go with the weighted moving average, because the data just does not work well with this particular method. And you have to choose a method that works better with your data. Now to exponential smoothing. I just cloned the worksheet again so that we start with the same table or the same sales figures that we have from the previous examples or the previous methods. So the way exponential smoothing works is a little bit different, but not totally different from what we've seen. The slides and the text, of course, explains what the formula is and how to pick the right values. In terms of how you apply it, you always start out where your first forecast is equal to the actual sale of the previous year. So in this case, because there's no previous year for 0, we skip 0. We cannot start with 0. We will start the forecast for year 1 as 110, because that becomes the that was the sale value for the previous year. Now, the question now is, how do we calculate the forecast for year 2 or week 2, sorry, and on like that. So what we do is we pick an exponential constant called alpha. Let's call our exponential constant 0.1. So we'll use this constant to smoothen out our forecast. How do we do that? The forecast for for week 2 will be the exponential constant 0.1 times the actual from the previous year, in this case 95. So that's this will be equal to let's see, 0.1 times 95 plus the forecast from the previous year, which in this case is 110, because that's really our starting point, 110, times what is left over when we subtract our constant from 1. So in this case, that will be 0.9. So times 0.9. If the exponential constant or the smoothing constant was 0.3, then what is left over would have been 0.7. Okay, so again, I'm going to do this for week 3 so that we can see how that works again. We go ahead and multiply this actual sale from the previous week, which is 105, times our smoothing factor, 0.1, plus the forecast from the previous week, 108.5, times 1 minus 0.1, which is 0.9. Okay, now when you look at it carefully or critically, because we are considering the forecast from the previous week or period, we are actually basically still performing a moving average, kind of, but we are smoothing it out so that it gradually um, gives lower significance to previous to older forecasts and higher significance to newer forecasts. So if we copy this equation, see how this will translate to other columns. This special formula. Okay. Let's see. Sure. Okay, I see. So instead of 105, let me use the field names itself. So this is going to be 0.1 times 1.5 plus 0.9 times previous forecast. Okay, so now I can copy formula. What I had before was actual values. Okay. All right. So now we have, I'm just copying the format here so this is more readable. A special it's formatting. Okay, there you go. All right, so 1 decimal place. Now let's look at our forecast accuracy for exponential smoothing. Our mean absolute error is 6.37. It's definitely better than weighted moving average. It's slightly better than our moving average forecast, and it's better than our naive forecast. So, of course, for this data set, the exponential smoothing gives us a better forecast than any of the other three.